Hi everybody, and here is the lecture number 4 and the materials that we're gonna cover today. And basically we're gonna start in chapter 20 first. We're talking about the electrical potential energy. And here's the chapter that we're gonna cover for today. And before we start in chapter number 21st, here is some your feedback or some your comment from your assignment number 1. And the first comment that I found here is based on the problem 2047, when you are given the carbon oxide molecules and given the carbon charge and the oxygen charge, what they are in distance 0.11 nanometers, and they ask you to find the net electrical force. And you are giving here, you already given your electrical field value. With that electrical field is 1500 Newton per coulomb. That electrical field toward the vertical direction. So this is our electrical field, uniform electrical field goes in the y on in the vertical direction. So here is the your, and since we have two charges, the positive and negative, so to find the electrical field or electrical force for each one of them. So here is the formula for the force. Just Q multiply by electrical field. Since the electrical field go in that direction is here, so the negative charge will be goes down and the positive charge for the carbons will goes up. Since they have the same magnitude as electrical field and they have different sign of charge. So the force in one of the end of the dipole or the charge is the equal the magnitude, but they are in the different direction. So you end up with the net force for that molecule will be zero. One of them positive goes up and the second one goes down and the net force will be zero. And for the ASCII for define the torque or net torque, you know guys, the torque is just force divided by D that we have covered in the 125. My force right now comes from the electrical charge multiplied by D, which distance here we have it. And we have a charge and we have electrical field and you have the length and you can find the net of the torque in that situation. That's the first comment. Go to the second comment here. The question asks, why do we use the sine for the horizontal component and the cosine for the vertical component? And this question is here basically in where the angle that you selected to choose for your vector. In this case, our vector is here. That's our vector. And if you want to type the angle, this is the angle here, but this is not the angle that we are considering. So I draw here two figures. And the first figures, I wanna, here is the force that I am looking for. And here is my X and Y direction, or my coordinate. And I will select this one theta, and this one, it should be 90 minus theta. And because this one is the perpendicular. By default, this one is theta will be. So if I consider this one is theta, this is the angle I will consider. And the second graph here, I will consider my T here, make this angle, I call it phi. Where is phi? Just 90 minus theta. That's my angle. You know, consider. So let's see that in first case, if I select it, the angle is theta is here. I just here's my close my rectangular. And we end up here is the component in this vector T in this direction because it's Y. And this directions here will be Tx. So basically we have that rectangular here. We have this rectangular in that situations. Okay, here is the angle here, and here is my angle theta. So from here, if I will type sine theta, what's supposed to be? Sine theta will be the opposite, tx divided by t. And from here, tx equal t sine theta. In the same approach, I can find ty equal t cosine theta. That's the first situation. Now the second situation, if I consider my vector, in this case is t, consider the angle, I will make analysis, it is phi, where it is phi is just 90 minus theta. So here is our rectangle that we're gonna use. This rectangular here. And this rectangular has two components. This one considered as the tx, because in located in the x directions, and this one is ty. So from here, if I want to type cosine phi or sine phi, let's start with the sine phi, which is supposed to be this rectangular length, which is ty divided by t. So from here, I can find ty on the y component. It is t sine phi, and which basically t sine 90 minus phi, minus theta. Okay. Similarly, you can type tx in the way that your questions here for the cosine. I can type t cosine, but not gonna be theta this time, 90 minus theta. So that both of them, they are identical here. These two formula here, where is my line? Those two formula, tx and ty, they should be has the same value for this component. They should be had the same. Okay, so that I hope that answer this question. So depending about the angle where you are consider your angle for your vectors. Now we're gonna stop for this recording and we're gonna starting our lectures in next video. Thank you so much, guys.